Okay, welcome to the video for day 3. Today we're going to talk about more solving quadratics by factoring. So we're going to continue doing exactly what we did in the previous unit and adding on the components that we talked about yesterday. So remember, just when we factor, we always need to look for a GCF first. Once you've looked for a GCF, then you need to look to see how many terms there are. If there are 2, we're looking for a D2PS. If there's 3, we're doing the trinomial factoring with the x in the area model. And if there's 4, it's already ready for the area model to use factor by grouping. So remember that when we're solving quadratics, that's the new component we added yesterday, we need to always start by having it equal to 0. So we're looking for any words that say solve for x, something like solve with a quadratic, find the zeros, roots, or x-intercepts. All of those things mean that we're going to set it equal to 0. Okay, so let's look at this first example. Remember, set it equal to 0. Keep x squared positive if possible. So I can see here that I have the 64 on the right. I'm going to subtract that over so that it's with the 16x squared. Okay, so now that I have it equal to 0, I'm ready to factor. The first thing we always look for is a GCF, and there is one. I can divide both of these. Remember that if you're not sure, you can go to the calculator and find the GCD. But if you know the factors, you might be able to figure out that 16 is the biggest. Otherwise, like I said, math, over to the num tab, down to number 9, which is GCD, and then you can use your calculator typing in 16, 64, and enter, and it'll give you the greatest common factor. So to factor out that 16, I'm going to put it in the box, and then I'm going to put the 16 out front, and then the leftovers on the top would be x squared and then a negative 4. Okay, so now I can rewrite this off to the back over by the equation so that I have the 16 and then the times x squared minus 4, the two dimensions of the box, the sides of the area model that we just wrote off to the side with the monomial and the binomial. So now I'm not done factoring. Remember, we always said factor until you can't factor anymore. So if I look here, this x squared minus 4, that's still a difference. Those are perfect squares. So that means this is a D2PS. And remember, I knew to look for D2PS because I knew it was 2 terms right away. Okay, so I'm going to rewrite this by opening 2 sets of parentheses. One parenthesis gets a plus, one gets a minus, and then I fill those in by taking the square root of each term. So the square root of x squared is just x. So I'm going to put that in the first spot of each of my parentheses, and then the square root of 4 is 2, so that goes after the plus and after the minus. Remember that the order matters. You keep it where it was in the original. Since the x squared was first, that's why it's in front. So now I have my 3 factors here. I have a 16 out front, and then I have the x plus 2 and the x minus 2. I'm done factoring now, so we can set up our t-chart between our factors. Okay, so on the left side here we have that 16, but 16, we can't change it. We can't make it equal 0. So 16 does not equal 0. That gets rejected. But these other ones we can set with x's. We can solve for x to make that factor into a 0 so that the product will then become 0. So I just had each factor equal to 0, and then on the left-hand side here, the x plus 2 equals 0. We're going to subtract 2 from both sides. So then I get my answer over here of negative 2, and on the right side, I'm going to add 2 to both sides. And then we get our answer of x equals 2. So remember, when we have solving quadratics by factoring, the most important thing to do is always look to see if there is a GCF first. Is there something that we can factor out? Then, once you have factored out a GCF, look to see what type of factoring would follow. If it's 2 terms, you're looking for a D2PS. If it's 3, you're looking for the x and a box. And then if there's 4, you're looking for factor by grouping. Now, the next one I actually want to talk about is I'm going to jump to number 3. In number 3, we have this x, and then in parentheses x minus 6, but we can't factor it yet because we have this 7 on the right-hand side. So we have to move this over, but we're going to need to be able to combine like terms. So the first step for this one is actually to distribute the x, and then you'll end up with an x squared, because x times x is x squared, and then the negative 6x, because x times negative 6 is negative 6x, equal to 7. Then you can now make this equal to 0 and solve by factoring. So this was a first step that you needed to do. And then you can factor from there. Now, in number 5 and 6, you're going to multiply out and combine like terms before you can start the process of solving by factoring. So in this one, we have this x plus 7 being squared. You need to set up an area model, because this is the same as x plus 7 times x plus 7, and fill in the area model. So put the x plus 7 on the outside and the x plus 7 on the outside, and then fill in and combine like terms to figure out what this is as a quadratic. Then you will be able to move over the terms on the right hand side here and set it equal to 0 and solve by factoring. So these, you need to do a little work first before you can use factoring for these two. Now, for this last page here, all I want you to do on this page for today is to think about these equations down at the bottom here. We're going to make some observations, but I want you to think about how are the equations below different from the questions on number 6, the one that we did previously. So how are these different than the two up above that I just talked to you about? So make some thoughts for that one, answer this question up here, and then we'll be able to go through the steps and solve these in class tomorrow. All right, have a great night. See you tomorrow.